All right, welcome back to part B of 1.2. So we're going to pick up where we left off with the previous one. The previous one, you were to study all three of these, and you were to draw the fourth figure in the sequence. Okay, and they gave you plenty of space there. Assuming these, what does the fourth figure in the sequence look like, and how many blocks does it have? Well, you should have recognized that this first block was 1 by 1 squares, a total of 7 1 by 1 squares. The second figure was a total of 7 2 by 2 squares. The third one was a total of 7 3 by 3 squares. So that means that my fourth figure better be a total of how many? 7 4 by 4 squares. Right? Well, 4 by 4 is 16. So what is 16 times 7? Well, I stack and multiply. 6 times 7 is 42. That's 7, 8, 9, 10, 11, 112. Okay? Should be 112 if we look at it. Let's see if we're right. At least see if I'm right anyway. I'm going to begin by filling in the table. Size 1, 2, 3, 4. Well, I haven't got the fourth yet, but I do have 3. And let's see if we can take this on. Size 1, that's pretty easy. I can count 7 blocks. Size 2, again, how did we do this? We grouped it into 7 different square blocks, 2 by 2. 2 by 2 is 4. 4 times 7, 28. How many are in 3? 3 by 3 is 9. 9 times 7, 63. So I'm doing that. I'm not counting 1, 2, 3, 4, 5, blah, 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 all the way up to 63. I'm grouping it. I've been showing you that for the last week and a half. Group things. Make it easier. All right? So 4. We have 4 by 4, which is 16. 16 times 7, 112. Right? So that's how I'm going to group this. Well, how many would be in 5? Well, let's just think. If 1 was 1 by 1, 2 was 2 by 2, 3 was 3 by 3, 4 was 4 by 4, this would be 5 times 5, which is 25 times 7 blocks, right? 6 would be 6 by 6 times 7. 7 would be 7 times 7 times 7. And so on and so on and so on, right? So we can do that. I encourage you to go ahead and pause and multiply 25 times 7. See what you get. 5 times 5. See if you can come up with the correct answers for 5 and 6. So if you need to, pause it. Unpause. 175, 252. That's a lot of blocks, but they're increasing at a pretty rapid pace. Now I look at my first difference and my second difference. Right? What is my first difference? Well, figure it out. What do I do to go from 7 to get to 28? Plus 21. 28 to 63. 63 to 112. Pause it. Use a calculator if you need to, and figure out what my first difference is. I'll give you a second to pause it. Unpause. I get 21, 35, 49, 63, 77. Now obviously that first difference is not the same. So I go with the second difference. Well, what is my second difference? How do I go from 21 to get to 35? Plus 14. 35 to 49 should be 14. 14. 14. Yes, these are large numbers. Don't let that freak you out. If you do the math right, then it should be a constant second difference. If you get plus 14 and say you screw up and you get 16, go back and double check your work. Okay? You should know by now. A constant first difference, it's linear. A not constant first difference and a constant second difference, it's a quadratic. So based off of what we discussed earlier, now I know my explicit equation should revolve around here somewhere. Okay? And we've got to do the graph. Well, again, the graph, we're going to look at size. What is my size? Well, my sample is 2, 3, 4, 5, 6, 7, 8, 9, 10. Pause and catch up if you need to. over here is still the number of blocks. Okay, the y is still the number of blocks, but now, how do we count the number of blocks? I'm even going to do it, then I did it different on my paper here. The number of blocks, keep it simple. My minimum is 7, my highest is 252, and it's probably going to go higher. So I'm gonna keep it simple, and I'm going to go 20, 40, 60, 80, 100, 20, 40. Actually, let's see. I did that wrong. I'm not going to do 20s. That won't give me enough. As you can see, I would run out of space. I'm going to do 50, 100, 150, 200, 250, 300, and 350. Okay? Again, so 50, 100, 150, 200, 250, 300, 350. The reason why I chose to go by 50s, all it's going to do is shrink my graph down. But I've got a large number here, 252. I'm still going to be way up here. So now plot these, keeping in mind y equals x squared. My graph better be curved when I'm done. So 1 is 7. That's going to be really close. 2 is 28. Well, 28, that should be 25 is half of 50, so we'll just go in the middle there. 3 is 63, just above 50. 4 is 112, just above 100. 5 is 175. That's going to be in the middle. See what happens? Now I can predict how many are going to be in 7. 7's probably going to be 300, 350, somewhere around in there. If I'd have drew a few more points, it made it a little bit better. Right? But there's the graph of that. The last thing is make the equation. Question 4 says develop a mathematical model. Well, we've done the model. All right? We've done the table, we've done the graph. Now we got to create the equation. Think about what I've done. I've given you some examples. I need to input something in here, 1, but I need my output to be 7. What can I input here? Well, obviously my input has to be 1. And I have to have a squared there. And my output has to be 7. So 1 squared is 1. What can I put in this box right here to get 7? 1 squared is 1 times what is 7? Well, obviously it's 7. But my input changes. When I put a 2 in here, what goes in the box so that my output is 28? Well, 2 squared is 4. 4 times what is 28? Gee, 4 times 7. So look at my explicit equation. Y equals 7x squared. Question this. Question that. If I put in 3, is my output 63? Because at that point I've already tried this 3 times. 3 squared is 9. 9 times 7 is 63. Gee, I think you found the explicit equation. Right? And that wasn't that hard. So they're not always. In question 5, compare the models that you developed for the first 2 set of logos. What's the difference? Okay, in what ways are they similar and what ways are they different? Well, the linear one was a constant first difference. The quadratic was a constant second difference. So a little compare and contrast. There's part B.